All right. Good morning. Happy Tuesday. Welcome back to another one of these new Tuesday editions of Deep Dive with me, Tim. So I shuffle around the windows here for just one more second and move the microphone the rest of the way out of frame. Get myself situated in the chair. All right, so first of all, welcome. What is up, Liz, over in the chat? Nice to see you this morning. For anyone who is new, move this out of the way here because we're going to use it in a little bit. For anyone that is new and doesn't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and this is a weekly live stream here on Tuesdays on the Adafruit channel where I work on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project, which is circuitpython.org right here. This is basically a version of Python that runs on tiny computers called microcontrollers. Typically, the way it works, you will plug these little devices into your main computer, your PC, your desktop, your laptop, whatever you may have. You'll plug it in with a USB cable. It will show up like a thumb drive, and you can edit and save a Python code file on the thumb drive. And when you save it, the microcontroller, the actual computer that's in these little chips, will interpret and execute that Python code for you. I did not set up was, well, okay, yeah, we can't use the camera though because we're using the this camera. Right. I don't need the other camera. It's gonna cut to a shot of the camera, but I did not set it up, and there actually was a reason past him on top of it and knew that we can't set up the camera because we're using the HDMI capture card. But this is a picture of a Fruit Jam, which is one of these little microcontrollers that supports CircuitPython, and this happens to be the one that I am using. This one has a bunch of built-in peripherals like some USB ports, some buttons, some NeoPixels, a Wi-Fi chip, an SD card, and a DVI video output signal connector that is shaped like an HDMI plug, which is what I have fed into the HDMI capture card, which is what we're able to see over here, which is why we can't use the camera that I was blabbering about a minute ago. So there are lots of different shapes and sizes, capabilities of these devices. They all have different bits and pieces built in or not. Some of them, like these Raspberry Pi Picos, are very basic. They don't really have much built in. The intention is that you'll connect up your own stuff with all these I/O pins that they provide, and others, like that Fruit Jam, are more purpose-built. They have the peripherals that kind of build it into a more specific sort of a thing, in this case like a mini computer or a primitive video game system. If you like CircuitPython and you want to help support it, it is an open source project that is primarily funded by Adafruit. They pay a team of folks, including myself, to work on the project. If you would like to help support not only CircuitPython, but the rest of the open source software that they pay people to work on, one of the easiest ways to do it is by purchasing hardware from them, which you can do at their website, adafruit.com. And as always for Tuesdays, if you check back later today for JP's product pick, there will be a specific item with a deep discount. So you can not only get yourself something fun to build a project with, you can get it at a great price later today during that stream. What is up in YouTube? We have Cornbread Ninja and Royal Bengali. What is up, my friends, over in the YouTube? Yes, so jumping in today, Arduino, no, we're doing CircuitPython stuff, so I'll bounce back to circuitpython.org, which is where you can learn more about it. It is kind of like an alternative to Arduino. It's a different way to program microcontrollers that is intended to be more sort of easy to use for beginners. Arduino is great, and Arduino lowered the barrier to entry to programming microcontrollers a long ways. From sort of like specialist engineer types down to hobbyists and students. CircuitPython is intended to kind of continue that simplification to make it even easier to program microcontrollers to do stuff. So it is sort of in the same universe as Arduino, same idea, but it is not the exact same. It's a different project that tries to achieve sort of similar stuff and goes about it a different way. You program it with Python code instead of Arduino, which is sort of C-ish in nature. Yeah, circuitpython.org, though, you can learn more. Arduino Q. I don't know about the Arduino Q. I remember hearing that it was getting announced. I think maybe some people have gotten it. I don't know too much about it, though, so I can't really answer any questions on that. Can you make a hacking device with ESP? Well, an ESP is just a microcontroller with a Wi-Fi connection, so kinda, yeah. I mean, like the flipper, I'm pretty sure is based on an ESP, isn't it? And that's a hacking device, basically. So, yeah, I mean, pretty much, yeah. What we are jumping into today, though, is this little cute Easter game I have hooked up. It is running on the Fruit Jam. I have the little SNES-like controller, these little Super Nintendo-like USB controllers. And in this game, you are this little rabbit character. You can run around the maze, and there are lots of these colorful eggs that are spawned into the maze. And the way it spawns the eggs, it kind of randomizes the pattern and the color. So there are lots and lots of different possible eggs that you can find. And this is kind of the whole point of the game, is just run around, collect the eggs, and then... Did we skip that one? I did. I'm going to go back and get this one, otherwise I'm going to have to do it at the end. Oh, go through here, and then as you can see, like lots of the map is covered up by the clouds until you like run near it, and then the clouds get cleared away. You kind of reveal the map. That's a neat like game mechanic that this project will demonstrate. All right, and then when you collect the last egg for the level, we get it takes you to the level complete screen, the end level screen. On here, you can use the cursor to select any of the eggs you want to keep. So if you're like, this little wave one is pretty cool, I can keep that. And I think also this yin yang blue green, pretty cool. The skull is pretty cool, but I have lots of skulls. The red and green kind of clash. Yeah, so those are probably good. And so then you can, like it says here, use the D-pad and the A button to save the eggs. Use the start button to go to the next level. It doesn't actually say that you can use the Y button to see your collection, but you can. So I just pressed Y, and it takes you to your collection. And now these are the eggs I saved. So the little green-blue yin-yang, the little tidal wave action there. Those are the most two recent ones that I just saved, but this is also paged, so I can kind of like use the shoulder buttons here, go back and forth through these pages. So that is kind of the gist of the game. You can close your collection with Y like it says. You can press start like it says to spawn a new maze and just run through it again and collect more eggs. And the eggs are, like I said, randomized, so you get different ones every time, and you can kind of just go and find ones that you like and save them. The ones that get saved to your collection here, inside your collection page where I can page through them like this, these are saved to CP saves. Anyone doesn't know, in CircuitPython 10-ish, I think, is when this was added. I'm not actually sure when the exact version that this was added, but Scott worked on this before he left for parental leave the most recent time. And this allows you to, so the CP saves is like its own little partition of the flash storage. You can write to there without having to do the whole remount, unmount, remount, that thing. So the eggs get saved into here. They're kind of like compressed down to just the index within the sprite sheet. And then these are a mapping of which colors are going to get mapped to which colors in the palette for the eggs. And so essentially this list right here defines one of these colorful eggs, and then the whole list of them, this is a long file that just stores all the ones you saved. They basically get rendered into this paginated list of eggs. I like this. I saved a blank one because I found a blank white egg, which I thought was cool. So that is the game. And what I would like to do is a few things during the stream. For one thing, we are gonna grab a couple of screenshots. Like, in fact, the next screenshot I need is the end screen. So why don't we run through one more maze here? So we're getting a couple screenshots because I'm working on the guide for this. So we're gonna grab a few screenshots, and then the other thing I want to do during the stream is walk through the code. Instead of doing a written code walkthrough page, what I'm going to do is just go through the code on the stream here, and then in the guide I will embed the video with a start time and say, like, here's the walkthrough. Instead of a text walkthrough, we have the video walkthrough from the stream. All right, so there's our end screen, and while we're here, honestly, we might as well, first of all, are there any cool eggs I want to keep? That's the most important question. This one's pretty cool. Should have visual feedback for when you save your egg. I just noticed it's not actually doing anything. So if we connect to the serial port, if I save one, kind of like this one. So it does save, it prints like diagnostic type stuff here, but there's no visual indication on the screen, which is unfortunate. We should probably add that. So I do know there are a few like things I'm gonna want to add to this after the fact. I kind of like forced myself to stop working on the code and get it submitted so that I could get the guide in before Easter, since it's like kind of Easter themed. But there are a few things I'm going to want to probably go back and do after the guide is done to the code itself. And visual output of saving, that would be a good one. Maybe we can add an icon or something that pops up in the corner. Not sure where the best place to do it would be, but to think about that. I'm going to get a screenshot of the collection page as well, because this is another screenshot I need for the guide. And then I want a screenshot of the maze world, but I want it like kind of partway revealed. I'm actually going to leave that egg there because I want lots of eggs in the screenshot if I can. I'm going to try not to necessarily collect all of them, although in some cases I have no real choice. Okay, this is pretty good, I think, actually. We have a nice chunk of the map revealed. We have lots of eggs. I think I'll have the character face the camera, maybe? For the screenshot. This. I'll bring this in a little bit. It doesn't use the full screen. Could it, though? It does look like it would be one tile width. In any case, like I was saying about the code, I forced myself to stop changing the code so that I could get the guide done in time. But that may be another thing. If there's actually just 16 pixels of blank here, then I could totally expand the map by one more tile. I'm not sure if that's the case, though. I have a flipper. Okay, yeah, so yeah, I mean, an ESP definitely can be made into anything, really, but hacking thing is one of anything. As always, I would say don't break any laws with whatever you make. Okay. And then I can never remember. Am I logged in here? I think. Yeah, I am. Okay. Although I don't have that one link that takes me to where I normally go. 1 second, we're just gonna do it this way. All right, peek behind the curtain of a guide in the works here for anyone who's never seen it. Go to here, so I want these screenshots basically here. So maze, I'm gonna do title and then screenshot. Yeah, actually, I think I kind of want to break that up. Title and then screenshot. And product guide, why is that the one it went to? That's interesting. We want the... Actually, did I not copy that one? Did not copy that one. I have now closed the folder. The last one. Okay. And actually, we could try side 2 on these. These could probably just be... Yeah, I think I want to try that. But I've already changed this. So we can change it. It is one way. If I end up not liking it, then we do have to re-upload, but that's fine. This to be 4x3. And this can actually just be in here, I think. And there, so usually I'll try to use these if there's kind of the right amount of text here that it won't be too long or too short. Maze World, we can get rid of this. And then we can do basically the same, except we don't have an image yet, so we can just make a side to end level. That was either I chose the wrong image or I gave that the wrong name. Gave that the wrong name. Wait, that's awfully tiny here, but it still looks wrong in that. Is it? Okay. Maybe it just doesn't update? It's awfully tiny as well, though. But it's that seriously looked like a tiny version of the old one. I think it probably just didn't update. Alright, so end level screen showing a grid of colorful eggs that were found during this round of the game. Yeah, that's like kind of perfect amount of text basically for a side 2. Let me double check. Okay. Lots of pink. I like pink in my eggs, it looks like. I wonder, it'd be interesting, you could go back and do stats or something? That could be kind of cool. Like which, you could have it tell you like which patterns do you save the most and which colors do you save the most. That would be interesting. For a time, kind of understand your colored egg preferences. Yeah, I like that. Okay, now I think we want to... We could just restart, actually, because basically what I want to do is walk through the code. And while we walk through the code, it'll be good to start from the beginning. And let's quickly skim it. Just so we know what we're in for here. So we kind of have, loosely it's broken down into like setup variables. Then there are a bunch of function definitions. Then there's also the player entity class, which is not a function, but is kind of a helper definition still. Then there are the actual sort of UI element variables. So the variables up here are mostly constants and just sort of raw data and stuff. The display does get initialized, but that's it. Down here, though, it's more display IO level stuff. So the UI, the tile grids for the... Well, we load the bitmap for the... We should have a picture of ready to go, actually. Let's open that up. Can load both of these, in fact, and zoom them way in. Okay, so we load the bitmap of the sprite sheet for the world. Talk a little bit about the ground tiles, which are the grass, the wall tiles, which are all of these, and the trees on the second row here. The eggs, obviously, are the bottom tiles. The clouds are over here. And then this one, this little colorful one, we'll talk about when we talk about the paint. Ply paint, is it? Yeah, ply paint function right here. Basically, the way the eggs are painted is it takes all the colors from this sprite tile right here. So this one's just kind of black with a bunch of different colors in it, and these colors exist not to be like drawn as an actual sprite in the game, but just so that the colors will get put into the palette. And what it does is it essentially remaps the different shades of gray that appear on the eggs. All the eggs are grayscale, and there's like, I think 5 or so different shades. There's kind of like a white, a light, medium, dark, darker, darkest kind of thing going on. And it basically swaps the grays out and swaps one of the colors in. And you could actually expand it as well. There's lots of empty space here. You could fill this up with more colors if you wanted more variation in your eggs. Be super easy to do. There's a couple of numbers in the code that would have to change as well. Like these ranges are kind of hard-coded. But like you change a few numbers, you change the image, and you make sure that it's ordered correctly in the palette, and you could get more colors. The other thing I may eventually publish is the helper script that reorganizes the palette. Yeah, I should publish that at some point. If people want to really go deep to make their own, then that thing will be helpful. It kind of reorganizes the colors in the palette to be in an order that makes it easy to do this swapping. Like, it could be done no matter what order they're in, but it would be a lot more random of like which ones get traded in where. I have the script that reorders it so that they're all kind of in chunks together. So it's like, take these 5 and remap them to these, 9 or whatever it is, randomly. Okay. So we have essentially 3 layers as well, right? So we have in the main like sort of world area here, we have 3 tile grid layers. We have the below tile grid, which is going to be all the floors, all the grass tiles, essentially anywhere that you can walk on, anything that gets shown visually below the player. We have the painters. These are for doing the coloring. We have the world player tile grid, Maybe not the best name in the world. Yeah, maybe not the best name in the world player. But essentially what it means by player is at the same level as the player. So this is saying like below the player, and this is saying at the same level as the player. It's not used in this game, but theoretically we could have an above the player as well. So this is kind of like the sort of sandwich stack of tile grids that represent what we see visually here. We do have the fog, which is above the player, but it's also sort of its own thing in this case. Okay, so this is at the player's level. There's the fog right there, which is like vertically, it does get spawned above the player, but I think of it differently because it doesn't interact with the rest of the map. So the sort of above tile grid that I'm thinking of would be more for like if we had a tree that was 2 tiles tall and we wanted the player to be able to run around and be like behind the tree. Visually, the way that would work is the top half of the tree would get rendered above, on top of, or in front of the player. If you imagine the stack of visuals that we're sort of looking at here. That's what that above would be. The fog is also above, but it's like not it doesn't matter what's where in the world. It's just randomly filled with the white tiles. In-screen tile grid. So this is this one. Well, specifically, it's the tile grid that holds the eggs here. There's also a label in the background. And actually kind of 2 backgrounds because the cursor is sort of a background tile grid as well. This one here. There's the background, there's the text. Then we have almost the same things for the collection screen. So that's this one. Obviously, it looks very similar. So in the code, it looks very similar as well. We have a tile grid for all of these eggs. We have the label, we have the background. So that's all of this stuff. Create a player entity, add everything to the main group so it can be visible. Start game is what generates the... Well, there is a generate maze function that start game calls, but start game does everything required to begin. So it generates the maze, it puts the player inside, it spawns the eggs, it colors the eggs, it kind of gets everything ready to go. It spawns the fog. It clears the initial fog around the player. Like when we first started this game, we have the little area around the player where we can see. So that inside start game, there's the very end of start game, it calls clear fog in order to do that for you. Then we have USB handling stuff. So it's the USB SNES controller. This is all setting up USB input stuff, USB host, creating a couple of buffer arrays to read the HID stuff into. Actually, here's a clear fog, but I think there's another one inside start game, so that's honestly probably redundant. No? How does it clear fog the second time, then? That is kind of weird. There must be somewhere in here that's calling it, because after you end one level and then press the start button, it calls start game again. It must be outside of start game. It must be in the start button handler, I guess. Yeah, there it is. Okay. Alright. I mean, theoretically, that should probably be moved inside of there. That's another thing I'll change when I do a refactor on the code. Okay, mystery solved. And then we basically just get into the main loop. We start reading from the controller, and then we have this sort of big gnarly if. It's not even just one if statement. It's actually a group of a couple of if statements, but this big gnarly if, you know, whatever button was pressed, basically. If the up button was pressed, then it's going to do this stuff here, which is like make the player move if you're looking at the world, or make the cursor move if you're looking at the end screen. If the up button was pressed, same thing, move the player, move the cursor on the end screen. Can I help you? Let's see. Fragrance Womer on YouTube says, hello, can you help me? I have a 2.8 inch TFT touch, but when I plug it in, it does not display. Can you help? I'm a noob. First, so I cannot necessarily help with only that information. My best advice, first and foremost, would be help. You're trying to use CircuitPython, first of all, I assume. Then go to the Adafruit Discord and go to the help with CircuitPython channel. 1 second, actually. Let me do this. Sorry, I need to do a little swap action here. I forgot to. On the Adafruit Discord, which is the link is down there. Down, I didn't see. I think I was probably pointing the wrong way. Oh, I was pointing the right way. Yeah, the link is down there. If you go to this help with CircuitPython channel, but they're going to need more information still. So like more specifically, what display is it? Can you link like is an Adafruit product or not? Can you link to where it came from? And can you link to like, are you using any code currently? And if so, like what is it doing? Does it, when you run the code, does it crash? Is there an exception? If so, put the exception in the chat room. Does it not crash but not show anything? Does the backlight come on? As much information as you can kind of give about what it is, like what code you've ran, what libraries you've installed, what versions, and then what it is doing or what it is not doing. The more specific you can be, the best chance you'll have for getting help there. There is also, if you're not using CircuitPython, I should mention, if you're not using CircuitPython specifically, which it says Raspberry Pi 4 and you're getting a white screen, so probably the backlight is turning on. It's interesting that it would be white. Usually those are black if they don't draw anything, so the fact that it changed to white makes me think like it's able to draw something, because usually it would be black, like I said. But in any case, if you're not using CircuitPython, there is also help with projects here as well. Or if you're doing Arduino specifically, there's that one as well. But help with CircuitPython would also cover if you're using Adafruit Python library. Like if you're using Adafruit CircuitPython, you know, SP whatever number, I don't know. There's a bunch of different display models, but ILI, okay. Yeah, I've used that display on a Pi before. It definitely can work, but it's just a matter of getting the right initialization and everything. I'd say definitely ask in the chat room. Okay, we got our button handlings. We're looking at D-pad stuff, so that we did up and down. Here's left is this one. So left for the player, left for the cursor, right for the player, right for the cursor. And then we get into the other buttons. So the A button only does something on the end screen, and what it does is save the current egg into the list of saved eggs, and then save that list into the file so it gets persisted. The Y button will toggle the collection screen, so no matter where you're at, you can look at your collection by pressing Y, and then you can also close it by pressing Y. This one just prints. I think this is just so I could see the other numbers in case I want to go back and use any more buttons. So like if I press, so like we're handling the A button, we're handling the Y button. If we wanted to handle B or X, we would need to know the numbers that they are inside of this protocol. This would print it for me. Start button only matters on the end screen. So if you're on the end screen and you press the start button, then you'll go back. It'll make a new maze for you. You basically start the level over, start the next level, depending on how you think of it. What do we have? Right shoulder button. So this only matters if you're in the collection page, and it just moves pages you through the different pages of collections. It does respect the maximum and minimum as well. So it won't let you go. It won't let you scroll to pages you don't have eggs for. It would be cool if it would wrap around, though. That would be another thing to add here. It'd be fairly straightforward, I think, too. We could just have some modulus instead of these if statements. And then this here is the fog handling. So every time the player moves, we get the location that the player's at, and we have these two sets. And they're sets instead of lists so that they won't ever, they'll be guaranteed to never contain duplicates. We have a scene tiles set and we have a processed tiles set. The scene tiles set, we add the tiles as the player sees them. So as the player's running around, every time they move, we get the location of the current like tile that the player's in, and we add it to that scene tiles list. Importantly, if it is not in the process tiles list, so we ignore any tiles that we've already processed. And we ignore any tiles that are already in the scene list as well. So you only see each tile. It won't repeat itself if it's already in the scene list, and it also won't repeat it if it's in the process list. So we add those to the scene list, and then we go through the scene list and we process each tile. To process it, we clear the fog from that tile, and we take any eggs that are there. So they despawn from the map, and they go to the end screen where the player has a chance to save them if they want. And then we add that location to the process tiles so that as we keep going through this, they'll now be in here so they won't get processed again. And then we clear all the tiles that have been seen. So we have now processed all the tiles that were in the scene list, so we empty out the scene list for the next iteration. And then this is just copying the buffer that we read from the USB device so that we can do debouncing, because like on the D-pad for the cursor movement, there's debouncing. If you press the button down and hold it, it'll only move the cursor by 1. Whereas in the world with the character, if you press the button down and hold it, the character will keep running, which is kind of how I think most people expect those to work. Okay. That was kind of long-winded, but it was a quick skim through. So now we're going to try to do a less meandering one. I just noticed this is actually cut off on the bottom. There we go. What was it? The whole second message is cut off. Goodness, okay. There we go. Sorry about that. All right, and I will kind of just go straight through since I'm going to link this section in the guide. I won't stop for questions or anything. Like I stopped halfway through that to respond, but this one I want sort of a cleaner tank to link to for people who just are looking for the walkthrough of this code. And then I'll get the timestamp after the fact. All right, here we go. What's up, everyone? This will be a quick walkthrough of the code for the Fruit Jam Easter Egg Hunt Maze game. The code for this game is fairly straightforward. It's broken down into a few different sections, but they are all part of one code file currently. So we'll just kind of scroll through this file and I'll break down each section, and we'll look back and forth between the code and the running program and talk about what each part does briefly. So at the beginning here, we have a bunch of variables to set some stuff up. We've got a list for some saved eggs. We've got some numbers that keep track of which page we're currently looking at on the collection page. We'll see examples of that as we get to it. But for now, it's just kind of a bunch of variables that are going to be used by the rest of the program. Here, we're loading the saved eggs from the file that's in the CP saves storage, is it partition? Or section of storage there. We've got constants for button comparison. These are the indexes within the HID sort of data packet of where we find which button's data. We have more HID constants. We have some visual UI constants, so the tile size. This uses a sprite sheet where each sprite is 16 by 16 tiles. And that gets divided out in a couple of different places. So that's stored here in a convenient variable. An index of a transparent tile. These are using the pink color for transparency. So for anywhere where there's pink in the sprite sheet, those pixels will not get rendered. And then this transparent tile here is a full square tile, 16 by 16 of transparent, that can be used to just empty out an area. We have all the tiles that are eligible to be used for grass, which are all of these ones up here. Those are just the indexes of those in this list, ready to go for later. All the wall tiles are also, they basically come after the grass here. So it's kind of all this stuff, the pumpkins, the rocks, the bushes, and the trees. And then we have A couple of wall tiles are special. They occupy 2 sections. So these fallen trees here occupy 2 tiles. Actually, they're 32 by 16 instead of 16 by 16, and those are just the indexes of those, so that the code can handle it later on. Those are the indexes for the fog. That's these cloud tiles right here. And then we have the egg tiles, which of course are down at the bottom of the spreadsheet here, all the grayscale eggs. And this gets the index of those, and a bunch of them are just in a incrementally counting range, so we use the range function there to make it easier. We have lists for walkable tiles, so basically these are going to define which tiles is the player allowed to walk on. And in this case, it's only the transparent tile because technically the floor is in a different tile grid. When the player is deciding where it can walk, it's looking at the tile grid for its own layer, and it is filled with basically the walls and the eggs and the transparency. And so the only places where the player can walk are transparency and eggs, i.e. essentially meaning the player is not going to be allowed to walk on the walls. We set up the display for the size we want, and then we have a boatload of helper functions. And so I'll kind of run through these quickly to tell you what they are, but we won't dive fully in depth to look at how they work. I'll just kind of give the high level what they do. So generate maze will randomly generate a 2-dimensional maze as a 2-dimensional list, I believe, a list of lists in Python, and each cell within that list will have either a 0, which represents a floor, or it will have a 1, which represents a wall. So this will just generate the data structure. A different part of the code will actually go and map that data structure to the tiles. So in this case, we have like the trees, the mushrooms, the rocks, those are the walls. And then the floors, the zeros, would be anywhere where we see the grass. But that is actually a transparent tile that's on top of the grass as well. Okay, so this generates the maze data structure for us. Get tile at pixel coordinates, just a helper function, very descriptive name that tells us what it does. You give it a set of pixel coordinates, and it gives you back the XY coordinates of the tile. Remember, these tiles are 16 by 16, so that's basically just dividing by that 16. Get the player tile, basically the same kind of thing. This, you instead of an XY pixel coordinate, you just give it the player object. It's going to give you back the tile location that the player is currently at. Clear fog, you give it the location where you want to clear the fog at, and you give it the tile grid that the fog is in, and it will clear a section of the fog away. So you can see here the player is in the center, and we have sort of this squarish, circle-ish thing around the player that we can see. And if I even move the player with the D-pad, as we move around, the section gets wider. We get more of it cleared out. So this is the function that is responsible for removing those cloud tiles so that it reveals parts of the map. Take egg, this will pick up any eggs that are at a location. So again, you give it a location, you give it the tile grid that contains the eggs, and if there is an egg in that location, then it will, despawn it from the map. It'll pick the egg up, put it in the player's sort of like inventory, where they can then save it at the end screen. Update collection. This will basically re-render the collection based on all the data from the saved eggs. So if we go back to the game, I'll press the Y button on the controller, which is going to show the collection page. And update collection is the function that gets shown when this page gets rendered. And it basically puts all these eggs in the tile grid for us. It sets the colors on them, and it loads them from the saved data file. So that's what's going on there. Toggle collection is the function that actually hides and shows the collection screen. So when I press the Y button on the controller, the collection screen shows, so it got toggled on. When I press it again, it got toggled off. Apply paint uses the tile palette mapper, which is a core module that allows you to basically have a specialized palette for tile grids where you can remap individual tiles within that larger grid. So if you have a grid that's like 10 by 10, you can remap an individual tile, say the index location of like 2, 3, X is 2, Y is 3. You can take that individual location and you can remap the palette there. So instead of red showing as red, you can change it to where red shows as green for that one specific tile. And this is how the eggs get painted. In the sprite sheet, the eggs are grayscale. They have just kind of like white and then a few shades of gray, and those get remapped using this apply paint function with the tile palette mapper so that all of those different shades of gray get filled in with a random color. Showed the end screen. So when you have collected all the eggs from the level, it will automatically show the end screen, which basically just, it's got its own display IO group. This will add it to the main group so it becomes visible on the display. So this gets called whenever the game notices that you have found the last egg for the given level that you're on. Player entity, this is a helper class that represents the player. So here in the game, we have the little player character, the bunny that runs around. And that is an instance of this player entity class, which is basically just a tile grid for the sprite, and then a little bit of helper logic for the animations. So there's different indexes for the player animations, because as the bunny moves, it's got a little running animation, so you can kind of see the feet moving there, and the ears sort of wiggle back and forth, very cute like. And those animations come from the player sprite sheet right here. Again, it's using pink for transparent. So we've got the little bunny, and there are 4 different sets of sprites, depending on which direction the bunny is looking. So bunny is looking towards the camera, away from the camera, to the left, and then to the right. And then each one of these columns is a step in the animation. And these lists right here just hold the indexes of those, and the code will cycle through those indexes as the player moves in order to apply that sort of visual running animation. Try move is where the collision logic is at. This will check to make sure that the player is allowed to move wherever the XY coordinates that are passed to here are. So as you hold down the D-pad, this try move function is going to get called, and it's going to check the world. It's going to check for wall tiles, and it will allow the player to move anywhere where there's not a wall. And anywhere where there is a wall, it will not allow the player to move. It will return false and stop the player from moving in that direction. Start game. This is a function that kind of encompasses everything that's needed when the game first begins. So it generates the maze. It hides all of the eggs inside of it. It handles all the coloring with that apply paint function. It spawns the player into a location. It kind of handles everything you need to start playing the game. Once this function is done, the player is sort of ready to start running around collecting eggs. And so it does all of that different stuff from generating random spawn points. There's where the maze gets generated. It clears out a bunch of the variables that are keeping track of all the eggs you've found this round or this level. This is where it's going to go through and like put in the walls. So this is what takes the data structure that generate maze created. Remember, that just generated a list of lists with zeros and ones. This is where those zeros and ones actually get converted to the tiles to get shown visually. And you can even see here, this is keying on that 1 from that data structure. So this is essentially literally saying, is the current cell, this is just looping over all the cells in the entire world, and this is saying, is the current cell a wall? If it is, then it's going to randomly select from those wall tiles to place a sprite at this location. If it's not a wall, then it will, it won't place a wall tile, it'll put a transparent tile, and then it will also essentially roll a dice to determine whether or not it should spawn an egg at that location as well. Next up, we have sort of the display IO initialization. So for anyone who's done display IO stuff before, this will look very familiar to you. We have a group to hold everything else so that we can show it on the display. We load up a sprite sheet using image load to just load that map sprite sheet right there. We have a below tile grid. This is the tile grid that's going to hold the grass in this visual level right here. So all these grass tiles are in the below tile grid. And in fact, even where there's like a rock on top of it, there's actually a grass tile below that as well. And it just randomly selects from the available tiles here, which is how it gets this nice sort of variation in the grass. It's not a super repetitive pattern, although there aren't that many, so it does sort of repeat to some extent. Painters, these are the tile palette mappers. Again, those are those things that let you map from the grayscale into the colored. This is mostly used for the eggs in this program. We have the world player tile grid. So this is the tile grid that is going to hold the walls, and it's also going to hold the eggs. And this is the tile grid where the collision is based on. So as the player is running, it's going to be checking this tile grid to determine where the walls are at and whether a player is allowed to move to a certain tile or not. Default palette, so this is just giving us the plain old list of colors as they appear in the bitmap. Later on, when it does that remapping, it will set stuff back to the default palette whenever it's done using that grid cell for the egg, essentially. Fog tile grid, this holds all of these clouds in the foreground here, so all these ones that are white are being drawn in the fog tile grid. We have end screen tile grid, so that is the grid that holds all of the eggs here. Whenever you get to the end of a level, whenever you've collected all the eggs on a particular level, it takes you to this end screen, and this has a grid of all the eggs that you found during that level. You can go through and save them by pressing the A button on them, but this is the tile grid that actually shows those eggs. There's also a couple of other display elements like the cursor tile grid, the background to be able to make that whole screen sort of lightly colored and have the same background. The text at the top as well, like this. So this is just all UI elements for that end screen. We add all of that stuff to a group because it is scaled by 2 as well. The world is not scaled by 2, but the end screen is, so it gets its own group for that. And then we get into the next display element, which is for the collection screen. So this is a very similar looking screen, the collection screen here, but this is all the eggs that you have saved. So the end screen has a cursor. You can use the D-pad to go through the eggs, press the A button on any of the ones you want to keep. When you save them, they'll get saved to your collection, which lets them show up on this page. So collection tile grid is this grid of eggs. And then again, we have the same like UI stuff to go along with it. We have the background, we have the text, we have no cursor this time because you can't go through the collection and do anything, but otherwise it's basically the same as the end screen as far as the UI of it's concerned. We create an instance of that player entity. We create a few more variables that keep track of which tiles we've seen and the eggs that we've collected this time around and all that stuff. And then we have our display IO stuff here where we're setting the root group on the display to be able to actually show the game itself. And then with all of this next chunk here, we have USB setup stuff. So we're using the SNES-like USB controller, and this code here is setting up that. So it's doing the USB core APIs. It's setting up a couple buffers to be able to read the HID data into. We clear the fog for the first time, so it clears that little patch right around the player when the level begins, and then we get into the main loop. And inside the main loop, the bulk of it is just to check, read data from the HID controller, and then check what buttons have been pressed and act accordingly. So we have kind of a bunch of if statements here that check different buttons. So we have kind of the D-pad buttons. Up button is this one. When you are in the world screen, it will move the player around. So if I press the up button here, the player runs up. When you are in the end screen, it will move the cursor. So that's this logic here. We have the exact same thing for the down button, both moving the player and the cursor. The left button right here, again, same thing for the player and the cursor. The right button, one more time, same thing for both of those. Then we have the A button. This one only matters on the end screen. So there's an extra if statement here that checks that. When you press the A button, it will save the current egg that the cursor is on. Again, those get saved into the CP save storage, so they're there persistently. The Y button will toggle the collection screen. So again, here, if I press Y, it's going to show the collection. If I press it again, it is going to hide the collection. That's what handles that right in there. We have the start button, so when you're on the end screen, if you press the start button, it will start the next level. It will respawn a new maze, it will respawn new eggs, and it will let you start again. The right shoulder button and the left shoulder button, these are only used in the collection screen, and when you are there, you can press the shoulder buttons right and left to go through the different pages of eggs that you have saved. And then right here, we have the logic for clearing the fog. So this is going through adding the tiles that the player is at to a set, a Python set, which is like a list. And then it's going to go through the list of scene tiles, and it's going to process each one by calling clear fog on it and by calling take egg on it to clear out the fog, the clouds around it, and then also to take any of the eggs that are there, to despawn them from the map, to put them in the player's inventory so that they can save them on the end screen. So that's what that's doing there. And then this very final bit is just copying the buffer from the one that was read from the HID, from the controller. This allows us to do some debouncing, like back up here in the D-pad buttons. When the end screen is showing, there's some debouncing, so that if you hold the button down, it won't just run super fast, the cursor. When you're playing in the map section, like here, when you're in the maze, you want to be able to just hold the button down and make the player run. But on the end screen, the cursor moved really, really fast. So we added debouncing there so that you press the button once and it moves the cursor once, so on and so forth. All right, that is the code. Real quick, fast version of the code for the egg hunt maze game. Be sure to check out the guide at learn.adafruit.com if you want to play this game yourself. All right, I will chop that out, or I won't really chop it out, but I'll find the section where it is, and I'll link that in the guide. And that was pretty good. I think the timing came out perfect. We are pretty much at time anyway. And I did have no more questions or anything come in, but if anyone does have questions, comments, thoughts, anything else you want to tell me or the rest of anyone watching, now's the time. Otherwise, I will probably start winding it down here. Maybe we'll run through this level as we wrap it up. All right, here we go. There we go. What do we like from this one? I kind of like this purple one. I like this one. I like this stripy green and blue one. Yeah. I think those are the ones I can't live without for now. All right. I'm going to wrap it up for now. Thanks, everyone, for watching. Do check out the guide. It should be out soon. It's not published yet, so you can't see it, but is in the works. It should be coming out hopefully this week before the Easter holidays. The goal, definitely. So hopefully within the next day or two, I will get it submitted, and then it will go through the review process and such. We'll get it out this week. So check out the guide, learn.adafruit.com. You can see this guide, lots of others as well. Again, huge thanks to Adafruit for supporting lots of the open source software that they do. For those watching, if you want to help support them and all the open source software that they fund by paying people to work on it, you can purchase hardware at their website, adafruit.com. Thanks to anyone who does that. And last reminder for JP's Product Pick is coming up later today, 4 p.m. Eastern, 1 p.m. Pacific. That is on the same channels that you are watching me on right now, so Twitch, YouTube, all the different places. If you come back today in a couple hours at 4 p.m. Eastern, 1 p.m. Pacific, you will find John Park with the Product Pick of the Week, where you can get a nice discount on whatever is the product pick this week. And that's it for now. So long. Thanks for watching. I will see you all next time. As far as I know, the plan is for Scott to do Deep Dive on Friday, and I believe I should be back on Saturday over on my channel at 10 a.m. Central Time for my stream. So on the 4th, Saturday, 10 a.m. Central, 11 a.m. Eastern, I'll be over back on my channel. So until then, so long, farewell, thanks for watching.